Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over how to write the expression for your equilibrium constant using the law of mass action. In this video and some following videos, I'm going to go over some practice problems. So let's get into this. So first of all, what is the law of mass action? Simply put, the law of mass action says that the equilibrium constant is going to depend on the concentrations of your products and your reactants. And so the expression for your equilibrium constant is written in the terms of molarities or concentrations, or if you have pressures, it's going to be in atmospheres. So it could be in pressure as well. And so we're going to write, or I'm going to show you how to write the expression for your equilibrium constant using this equation right here. So here's a generic equation. We have two of A, whatever substance A is, plus one of substance B, and that's in equilibrium with the product of three C's. So how do we write the expression for the equilibrium constant for this reaction? Well, the thing you got to remember is it's going to be basically products over reactants. So it's going to be the concentration of products over reactants, and each concentration, each product and each reactant is going to be raised to the power of its coefficient. So what does that mean? So let's go ahead and get started. So here's my K. So here we're going to say that K, the equilibrium constant, is equal to products over reactants. Well, what products do I have? So let me write this here. So it's going to be the concentration of products over the concentration of reactants. And so the only product I have is C. So if I'm going to write this correctly, it would be the concentration of C. And if I had, let's say, for example, if I had another substance D, then I would be multiplying that as well. I'll be multiplying the concentration of D if I had another product. But I don't have a product for this. I don't have another product for this reaction, so it's just going to be C. Okay, so now what about this 3 here? Well, that 3 coefficient becomes a power of 3 for the concentration of C. So this coefficient becomes a power. So it's going to be the concentration of C cubed, or to the power of 3. Now that I'm done with my products, now I just have to do the reactants. And in this case, I do have more than one reactant, so I'm going to multiply those concentrations together. So here's my first reactant. So it's going to be the concentration of A. And since A has a 2 coefficient, that's going to be a power of 2. So I'm raising that to the power of 2. And then I'm going to multiply that by my next reactant, so the concentration of B. And since the coefficient here is 1, we don't write ones, but it's there, that means that it's going to be raised to the power of 1. So I don't have to write the power of 1. We usually don't write the power of 1, but just to kind of make this more clear, there's the 1, right? So you could write the 1. Usually you don't write the ones. So this, ladies and gentlemen, would be your expression of your equilibrium constant according to the law of mass action. You can see here that the constant depends on the concentration of products and concentration of reactants, all of which are raised to the power of their given coefficients. And that, ladies and gentlemen, is how it's done. So if you enjoyed this video, if this was very helpful in helping you understand how to write your expressions for K, given the law, using the law of mass action, then please, by all means, like the video, hit that like button, share the video with your friends, subscribe to my channel. Make sure you hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.